Alright, hi everybody, let me just make sure that's recording. We're good to go. So what we did yesterday, what we ended off with was we were looking to see, we have this GIF, and there's a lot of examples of it online. I wanted to do it in real life, but it's really cool. It's this magnet, it goes through a copper tube, and it falls really slowly, and that is like directly contrary to what we know about falling things. Things should not fall this slowly. So this is like a really satisfying thing to watch. It's very cool. And it's just really cool. It's really satisfying, really cool to see this happen, to see this fall so slowly. Thank you to the 4 people who responded to this Flipgrid. And we had some really good really good explanations. I was really impressed with a lot of them. So yeah, they were really good. Aiden had some really good visuals in his, if you want to check that out. And I'm pretty much going to talk through it, but honestly, if you want to just watch Aiden's, he did it perfectly. He had a great explanation. He said he disagreed with Josh, but they pretty much had the same ideas, so if you want to check out Josh's too, see what he disagrees about. But yeah, Sophie did a good job explaining it, Mark did a good job explaining it, and you guys did a good job really verbalizing your ideas, so it was great. So again, I'm just going to kind of go through Aiden's, but let's just say, okay, we have this copper tube here. We're kind of looking at like a cross section, so let's pretend that we cut it right down the middle, and we're really seeing these 2 walls. So what we're saying is we're going to drop a magnet down there, and here I kind of drew my magnet off to the side. So we have our magnet here, and we're going to drop it, and it's going to go down this tube. So it's falling down this tube. We said yesterday that when the magnetic field is changing within a coil of wire, then that's going to induce a current within that wire. So what we can think about is this copper tube is really just a bunch of compressed coils. So we can think about, here's like one coil. We kind of have a bunch of these coils just stacked on top of each other. They're so thin, but a tube is essentially just a bunch of coils. So we're saying when we change the magnetic field within a coil of wire, that is going to induce a current in that in that coil of wire. So we're changing the magnetic field by dropping this magnet in here. So that's going to induce a current. So we have this action going on. Now we have a current. Now it's a top view. There's now a current going around that loop of wire. And then just like Aiden said in his video, I don't remember if I drew it down here or not. Now based on our second right-hand rule, we have induced, because we have a current flowing through there, that current is also creating a magnetic field around it. So it's crazy. We're kind of doing, this is making a magnetic field, and then that's making a current, which is then making a magnetic field. But so we have this current going around on this side, on the, what is that, I guess the left side that we're looking at, the current's kind of coming out. The direction doesn't matter, but so it's kind of coming out and then looping around like that. So on one side it's in, one side it's out. So we're making this magnetic field that's kind of pushing, they're going in this circular path. So we have a magnet interacting with the magnetic field, and that's going to give us a little bit of force. So this whole entire time we have this magnet going down. It's going to be wanting to fall down. Josh did a good job like putting this force body diagram in his. We say we have this gravitational force going down, and then this magnetic force going up, and this magnetic force is just from this interaction of these 2 magnetic fields. So thanks for the people who did this Flipgrid. I thought it's a really cool, I think it's a cool platform. Let me know if you guys don't like it. But I think it's a nice way that we get to kind of still interact with each other and then practice verbalizing these ideas. But yeah, so based on what we learned about electric guitars, now we can explain this cool phenomena. So what we're going to do today is look a little bit more into phenomena that happen with this induced current. So we're going to dive a little bit deeper into it and get some new equations. And yeah, so I'll see you in the next video.